All right, team. Here we go. Here is the topic. Remember, a mechanism is this how the atoms collide in a series of steps, elementary reactions. And here's what a reaction profile looks like. All right? It's the energy, the potential energy of our reactions as they go, the reaction coordinates as they progress through a reaction. This one mechanism has three elementary steps. And our goal is to sketch and interpret these things. So if you look at this thing, you'd need to know a little bit more information than this, not just the number of steps. You need to know things about them. But our goal is for you to draw them as well and then look at them and be like, is it right or not? And this is not correct. And we'll learn why it's not correct uh, in this video. I want to just have them with you to show you what they look like and have so you have a good idea what they look like. Our x-axis is the reaction coordinate, as it says. Remember, it's not like a true x-axis. It's like a map through the reaction. You're charting potential energy. Here's what the profile is going to look like. These really should be straight down here and here. It's going to have a series of bumps, all right, and they're going to be in various ways. We'll look at some. It's going to have some things I want you to mark are these peaks, mark this valley, and mark these heights here. And this height it's sometimes written like this. It's basically how big of a hill you have to climb. These heights are going to be really important, especially for a mechanism. All right, before we actually look at some examples, I want to just pick this apart and give you some information. I want to talk about these peaks, these tops. These peaks are where we've got an activated complex, where the molecules are coming together, breaking old bonds and forming new bonds. All right. My valleys, and this has one valley between two peaks, is an intermediate. That's where I'd find my intermediate. And now on the graph that I gave you, here are what they are. So A and C1 are these two guys are my activated complexes, sometimes known as transitional states, and B is my intermediate. Now, I want to break this thing down even more, and I want to talk about the steps. A step is up and over a hill. This has two steps, and that tells us that there are two elementary reactions going on in this mechanism. All right, I've got one bond being broken and made, and then a new one being broken and made. All right, or one bond being made and another bond being made. You'd have to look at the actual uh, mechanism. The change in potential energy is going to be like here to there. All right. Now you'll notice that's a positive change. That's a step, and I'm going to call that a step up. It's a positive change. All right. What that means is this elementary reaction or this step in the mechanism is an endothermic process. It's gaining energy. Whatever uh, chemicals involved are gaining energy. Therefore, they've got more potential energy. And this is number one, and it's going to come up here on the thing. Now that's as I've drawn. The endothermics look like that, where you go here and then you go up. All right. Now, if you look on the other side, and this is you're looking really at this distance. You're charting that distance from where they start to where they end. That distance is a negative potential energy gain. And that means this step, number two, is an exothermic reaction. And the classic exothermic reactions, they look like this. They go up over the hill and then down to the bottom. All right. Now, one other important feature of these hills is the height. And the height is really important. And the height of the hill. And the height of the hill is this here and here. All right. And it's also going to be sometimes represented with arrows. That's how I'm going to represent it. All right. I'm going to draw them in a moment. There they are. All right. Sometimes you'll see them with like lines, like it's showing you a line, like a distance, and they mark the beginning and the end of it. What this height is, it's the activation energy of the reaction that is occurring. It's charted telling you how much energy you need to give these chemicals so that they can change into your intermediate or change into your product. They can react, they can form a new species. And this is going to be really important for a mechanism because the mechanism is often has a slow and fast step. And the activation energy is mainly or is one huge factor that determines what is that slow or fast step. And you probably have guessed it. The bigger the hill, the higher the activation energy. The big hills, that's my slow step. The small hills, that's my fast steps. All right. And I've drawn these in. So you've got this huge whoa up over the hill. That's a big hill to climb. It's a lot of you got to give those things a lot of energy. That's why it's called the slow step. Where this is just like you can like run over it. Here you'd have to like train. All right. Now I want to go over do one example with you. How many steps is here? How many hills? One, two, three. So three elementary reactions. What type of reactions are these? That's a step up, endothermic. That's a step down, exothermic. Step down, exothermic. My overall is from start to finish, step down, exothermic. Now, what's the slow step? Boom, second one, highest activation energy. Okay, how many intermediates? At least two. All right. How many transitionary states? Three. All right. Okay, one more example, or a few more examples. How many steps? Three. Types of reactions: endo, exo, slow step, uh, second fastest step, second slowest step, first one, then the third one's pretty quick. All right. Ooh. Okay, how about this one? Overall react. Wait a second. This one. Overall reaction, endothermic, start to finish, definitely gaining energy. First step, endo. Second step, endo. Third step, exo. Slow step, second step. All right. Rate determining step, probably the second step. All right. And that is everything. All right. I hope you're all set and have a good night. Bye.